Hello, this is part 2 of how to do dynamic painting in Unity, and in this part we're going to be rendering the mask. First off, there was a bug in yesterday's code, and this one, Unity Matrix MVP, it's not supposed to be that, it's supposed to be underscore object to world, because we want the o.world pos to be in world position and not in the projected camera position. So just change that. With that out of the way, we have to change the level because the cube in Unity, since we're drawing the mask in texture coordinate space, Unity's cube wouldn't work very well because the UV coordinates of the cube is pretty messed up. So we need to change the cube to be a plane. So I'm just gonna do that real quick. Okay, so it's basically the same setup. I think we can play and you can see it. Yeah, so it's basically the same setup, but the only thing is I'm not using cubes anymore, I'm just using planes, because the texture coordinate of cubes in Unity is pretty messed up. Every side has the same texture coordinate, and we don't want that because when you're drawing in texture space, everything will be unwrapped. So when every side has the same UV, it just doesn't work. So yeah, so I'm just changing that. Okay, so now we can continue. Next thing to do is we have to make a script that will do the rendering for us. So let's make a script called the painter script. Painter script. Okay. And this painter script will be attached to an object. Let's call this painter J, and then we remove the box collider and disable the mesh renderer, and then attach the painter script to it. Now in painter script, what we need to do is, first off, we need to find all the objects that can be painted on. So let's do paintable script array paintable objs, and then over here we do paintable objs is equals to find objects of type paintable script. Okay, so now at this point we have all the paintable objects in paintable objs array, and yeah, so let's write. So this is what we're going to do. We're going to first disable all the renderer in this object, and then draw on each one of them as we want the code to draw on whichever object that we want it to draw to. And then after that we enable everything again. So we make a function for that, void toggle objs, and then we say toggle var, and then over here we do for each paintable script and script in paintable objects. We do mscript dot game object dot get component renderer dot enabled is equals to toggle var. Okay, now over here we do first off we do toggle var toggle objs false, and then we do toggle objs true, and then inside this we want to do a raycast from the middle of the screen, because we have a crosshair, we have like a red dot in the middle of the screen. See that? We have a red dot in the middle of the screen, and we want to raycast from that point to whatever object that we're going to hit. And we're going to do that when we're holding down the left mouse button. So first let's do if input dot get mouse button 0. So this is when we hold it down, we cast array. So we make array is equals to camera main screen point to array, and then we do new vector3 that. Okay, we're good. Now with this ray we can check for the hit, so raycast hit, and then we do if physics dot raycast ray out hit mathf infinity. Okay, so we check if we've hit an object, check if that object is paintable. So first we do paintable script, and script is equals to hit dot game object hit dot transform dot game object dot get component paintable script. Okay, and then we can check if it's null. So mscript it's not equals to null. If it's not equals to null, we can paint on it. Now if we can paint on it, what do? Well, we call a function mscript dot, let's call the function paint mask. We haven't made that function yet, and then we pass it hit dot point because we want to know where we hit on the object. So let's go to paintable script, and let's first disable this thing, disable the whole update, and then we do public void paint mask, and then we pass in a vector3 pause, and then over here what we want to do is, so first of all we want the camera to be able to see the object. So what do? We just move the camera to be able to see the object. So, and then we would need a normal, I guess, for this. So is it over here? Yeah, so let's pass in the normal as well. So hit dot normal, and then over here we would need vector3 normal, and then we can do mask camera dot transform dot position is equals to pause plus normal. So it will place the camera right on top of where we hit it, and then after that we do mask camera dot transform dot rotation is equals to quaternion dot look rotation negative normal. So when we do that, we're sure that the camera will see the object that we hit, and it will hit it, and it will see it at the point that we hit it. But although it doesn't matter because it'll unwrap the object anyways, but we can be sure that the camera sees the object, so that's good. Now we need to pass this position, the hit position, to the shader. So how do we do that? Let's go back to the shader, and then we add 3 variables. So underscore hit pause x, and let's call it pause, and then it's a float 1.0. Okay, so now that's for x. We do for y and z. So that's y, and that's z. And this is x, y, z. Okay, so now let's make a uniform variable in the shader so that we can access it in the fragment function. Let's do uniform float underscore hit pause x, and then we do Y and Z. Y, Z. So Y over here and Z over there. Now, in the fragment function, what we need to do is we need to check the distance between the hit position and the current fragment. So if O dot world pause dot xyz, and we want the distance, so we do distance, and this distance is a function that is already inbuilt into the shader. So float 3 underscore hit pause x underscore hit pause y and underscore hit pause z. Okay, and if that happens, then we just want to return float for, we're going to return red, so 1 0 0 1. Okay, and otherwise we return 0. So when we do that, we can now pass the positions, the hit positions, to the shader. So we can say material, let's get the material first, is equals to get component renderer material, and then we just pass the thing. So mmat dot set float underscore hit pause x, and we pass in pause dot x, and do the same things for y and z. So y, z. Okay, and then before we do all the, okay, and then we need to render the camera. So mask camera dot render. So before we do all this, because we have disabled the renderer in the object, we want to re-enable it so that the camera can see it. So let's do that real quick before we do anything. Dot enabled is equals to true, and then we set it back to false after we render it, so that the other code, the other painting code, will not be disrupted by this. Y there, Z there, Y and Z. Okay, so now we need to make a material for each of these things. We need to make a material for the level geometry. So let's create material, and let's call it paintable matte. Okay, and then we just put it as a material for all of these. So let's do that. Okay, we're done. Now, to see whether it works on the level, we'll just set the main texture of the new material to be the render texture. So renderer dot material dot set texture underscore main text, and we pass in mask shade the texture, which is mask texture. That. Okay, now let's check. Oh, we haven't this we have to smaller than 3. Yeah, because this is, the shader had an error, so that's why it didn't work, but now it should work. See that? You see? So this works, but we want it to stay there. We don't want it to refresh, right? We want whatever we have drawn to be wherever we have drawn. We don't want it to be gone. We don't want it to be a circle moving around, but we want it to be like a paint. So what we can do is, first, the circle is too big, so let's make it smaller. 0 point, let's say 7. Let's try that. Okay, that's better. Now let's make it stay. So how do we make it stay? So first, we have to pass in the render texture into the same shader. So let's underscore mask text, and then we create a sampler so that we can get the pixel value. So uniform sampler 2D underscore mask text, and then we check the color. So okay, so if it's not smaller, then we check the color. So if we get the color first, so float for call is equals to text to D, and then we pass in underscore mask text, and then it's o.uv because the UV coordinate of the texture, and we check if this color, if the color, if call.r is greater than 0.1. That means we have drawn on it before and we want to just make it stay red. So let's do that. Otherwise we make it black. So now, oh, we haven't passed in the, yeah, we haven't passed in the thing. So let's do that. And just change main text to underscore mask text. Okay, now we should be able to draw it like that. Pretty cool. Okay, so yeah, so that's how you do dynamic drawing. And then in my video, like I had like a texture on it, and then I'm just using this as a mask to draw on it. And also you can see that this is the resolution is pretty bad here. You can see that it's jagged, and to solve that you can do MSAA, and then you can do like a blurring technique. You can you sample 9 pixels around the current pixel that you're in, and then just blur all of them, and then that would make it more smooth. That would make it smoother. So yeah, but this is the basic idea. Like you can basically draw on anything at this point. So you can, okay, for example, right, let's make a sphere. Let's make a sphere, 3D object sphere, and then we just attach the paintable script on it. Copy component and paste it into the sphere. Here, let's paste it. This component is new, and then we just give it the same material, the paintable material, and that's it. It's now paintable. The sphere is now paintable. So when we move it here, and then we can probably make it bigger as well. Let's make it bigger. That it's not in the paintable layer. We have to make it in the paintable layer. Now it should be drawable. See? Pretty cool. We can draw on the back as well. See? Because the models are unwrapped, so you can have like any arbitrary shape. You can have anything. You can have cylinders, you can have spheres, you can have anything. You can have a cube, but the Unity cube, the UVs are all messed up. I mean, you can go to Maya, and then you can create a proper cube with non-overlapping UV coordinates, and then you can draw on it. Pretty cool. So yeah, so that's the basic idea of how to draw in Unity. And you can see there's the shadows work. See, because we're using the same shader as the surface shader. Only thing is we're drawing a mask and then we're using the mask to draw on the thing, so on the surface shader. So yeah, ta-da! Alright, see you. I'll see you next time. Peace.